Ladies and gentlemen, attention please. Ladies and gentlemen, dear friends, good afternoon. Today, we are delighted to hold this workshop on From Dream to Delivery, CNNC Nuclear Energy Solutions. My name is Zhang Guowei. I'm the Deputy Director of Research and Development of CNNC. It's my great honor to guide you through this exciting event. As we all know, nuclear energy is expected to play an important role in driving economic growth, ensuring energy security, accelerating decarbonization, and making our world cleaner and beautiful. But how can we make this vision a reality? How do we move from nuclear dream to tangible delivery? To begin with, please allow me to introduce our distinguished guests, including Her Excellency Sama Bilbao Leon, Director General of World Nuclear Association, Mr. Cao Sudong, Executive Vice President of China Nuclear Energy Association, Mr. Xin Feng, Vice President of CNNC, and Mr. Zhang Yanjun, President of China Dongfang Electric Group. Let's give them all a round of applause. 请大家鼓掌欢迎。Now, I would like to invite Mr. Xin Feng to deliver a welcome speech. Please, Mr. Xin Feng.
Hello, everybody. My English is not so good, so please allow me to speak Chinese, OK? 好，尊敬的萨曼女士，尊敬的曹世东先生和尊敬的张总，各位女士们、朋友们、先生们，大家下午好。首先呢，很高兴在核工业这样一个展览期间，同来自全球各国的我们世界同行们、朋友们，我们共同齐聚一堂。首先呢，请允许我代表 CNNC 向各位嘉宾和朋友的光临表示最热烈的欢迎和最诚挚的感谢。长期以来，中核集团始终致力于推动核能安全高效发展，助力全球能源转型与可持续发展。我们不仅是中国核电事业的开拓者和主力军，更是全球核能产业的重要建设者和参与者。今天我们带来的主题是从梦想到交付，中核集团的核能解决方案。这既是对中核集团数十年来持续奋斗与创新历程的总结，也展示了我们在全球能源合作领域当中的坚定信心和务实行动。对我们而言，从梦想到交付，这不仅是一句口号，更是我们中核集团在过去40余年不断探索、不断创新的真实写照。40余年来，中核集团构建了涵盖油矿勘查、采野、核燃料循环、装备制造、核电设计、工程建设、运行维护到核技术应用的完整产业链条，实现了从源头到交付的全流程一体化管理。在核电设计与建造领域，我们在连续40余年不间断从事核电设计与建设的基础之上，以数字化、智能化为驱动，不断提升核电工程建设的安全、质量与效率。在核电运行领域，中核集团拥有在运的核电机组26台，在建机组19台。2024年，我们瓦诺指标保持了世界领先，满分的机组数量达到了22台。在核能综合利用领域，我们已在供暖、供热、同位素生产、海水淡化等方面取得了很多的突破。 为社会经济发展提供了更绿色、更低碳、更多元的解决方案。女士们、先生们，核能是实现全球零碳未来的关键力量。面对能源转型与气候变化的共同挑战，中核集团愿与世界各国伙伴携手，强化创新与合作，共同推动核能事业的高质量发展，共创更加安全、高效、可持续的能源发展未来。最后，我衷心感谢各位长期以来对中核集团的关注与支持，也预祝本次主题推介会圆满成功，也祝大家在本届展览会期间收获友谊与合作，共同见证核能的美好未来。我就说这么多，谢谢大家。Thank you very much.
Thank you, Mr. Xinfeng, for your inspiring remarks and encouragement. Now, next, let's welcome Dr. Sama Bilbao Leon to share her perspectives. We are very eager to hear WNE's insights on the future of nuclear energy. Your Excellency, the floor is yours. Please.
Thank you very much. Well, it is truly a pleasure to be able to join you today in this China National Nuclear Corporation showcase. I think that, well, I don't know whether I'm the only one. I'm certain I'm not. It is truly exciting to see so many colleagues, so many friends from all over the world to actually see the vitality and the excitement that is happening in the global nuclear industry. So thank you for CNNC for hosting us, and also congratulations. I know we are going to have now a few overviews and presentations of the remarkable achievements from CNNC, because frankly, I think that in many countries of the world, we really are looking up and we are being very inspired by the delivery of projects on time and on budget that we are seeing in China. So let me just say very quickly, deliverability is not just about building fast, right? It is about building right. And I think, as you have heard me say very many times, we really are moving as an industry from going to many first-of-a-kinds, from many individual projects, to actually having programs, to actually having fleets. And this is a little bit the example that we have from CNNC, where after many years of repeating and doing projects very effectively, they have become incredibly effective and incredibly timely. So I think that this importance of constructability and deliverability is very, very important. And as I said, CNNC meets this goal of engineering excellence, but also this long-term strategic vision. So I will highlight maybe a couple of things that probably we will hear some more. I think that one of the most impressive milestones from CNNC is the successful construction of the first-of-a-kind Huanglong 1 reactor at Fuqing Unit Number 5, which was completed in only 68 months between May 2015 and November 2020. So that was a very important feat, but what I think is even more encouraging is now the progress on the Zhangzhou Unit 1, which is a near-series reactor in which the completion has been realized at only 61 months. So we are achieving efficiencies as we move forward. So, but this is not just numbers. I think that we really, what we are saying is a testament of the leadership of CNNC in nuclear project deliverability and constructability. And then we probably are going to see that it's more than just nuclear reactors. It's also going beyond electricity generation, because also there is leading projects in diversifying applications of nuclear energy that we probably are going to see. For example, the generation of steam and electricity at Tiangwan, where we have 2 BBVR reactors that are providing 600 tons of steam per hour 250 degrees over 23 kilometers to the petrochemical industry in a nearby area. So again, this is a powerful testament that is not just electricity. Nuclear, as you very well know, is a golden opportunity to help decarbonize the entire economy. And of course, CNNC has pioneering projects in other areas such as breathing reactors and even fusion. So I just want to close, but remind all of you something that is not new to any of you. So I think it is clear there is consensus in our society, in many countries all over the world, that nuclear energy is not just a cornerstone for clean energy, but very importantly, is absolutely essential and a very versatile tool for sustainable development. So whether we are talking about electricity or district heating or industrial heat or medical radioisotopes, etc., nuclear is providing incredible value across the entire economy. So I'm going to stop by encouraging everybody to bring the nuclear community together to replicate these successes. I think that we truly have a unique moment in history. The stars are aligned for many decades. We have governments, we have the finance community, we have the large energy users, we have in many countries the public, the civil society, the media. This is an opportunity that we, the nuclear community, cannot miss. We really need to step up to this opportunity, and it's a great opportunity to work together, to learn from each other, and to actually implement the successes. So in this case, I think that we are going to hear a few good examples from CNNC about constructability, about streamlined licensing, and about how to collaborate and fostering international collaboration. So I will stop here, congratulating CNNC, and once again thanking you for the opportunity to be here today and speak to all of you very briefly. So thank you for your past achievements and all the best for future achievements. Thank you.
Thank you, Sama, for your valuable insights. Now it's my pleasure to invite Mr. Cao Sudong to deliver his speech. Please, Mr. Cao.
非常高兴参加这个发布会啊，尊敬的这个萨马女士，尊敬的新丰副总经理张总，尊敬的各位嘉宾，大家下午好。首先呢，对中核集团主办的从梦想到交付这个专题发布会啊，表示衷心的祝贺。中国核能的发展呢，本身就是一段从梦想到交付的历程。我们呢，怀着从建设自主核电的梦想，从零起步，艰难探索。随着秦山核电站的并网发电，中国人第一次点亮了属于自己的核电之光。从引进来到走出去，一步一个脚印，中国也形成了自己的完整的核能产业链。在这个过程之中，中核集团发挥了主力军的作用。它不仅是中国核能产业的中坚力量，更是全球核能舞台上的重要参与者。中核集团的一体化核能解决方案，也并不是一个抽象的口号，而是几十年积累的系统能力的集中体现。从设计研发到工程建造，从运维管理到综合利用，中核集团已经能够为全球的合作伙伴提供全链条、全周期的服务。在实际建造方面，中国不仅追求速度，更注重质量与安全。无论是在国内大规模的核电建设中积累的经验，还是在海外项目中展现的跨文化领域的能力， 都证明了中国核能产业已经具备世界品质。这种品质不仅体现在技术指标上，更体现在对安全的坚守和责任的担当上。此外，华龙1号作为中国自主3代核电技术的典型代表，已经成为中国核能走向世界的一张亮丽名片。它不仅在中国国内多个项目中实现了高质量投润，更在海外成功落地。目前已经成为全球在润在建数量最多的3代核电技术，总量已经达到了41台，充分展现了中国在反应堆设计、安全标准、设备制造和工程管理等方面的综合实力，为全球清洁能源发展提供了可复制、可推广的中国方案。女士们、先生们，今天的世界正面临能源转型和气候变化的双重挑战。核能作为清洁、稳定、可靠的能源选择，正在发挥越来越重要的作用。中核集团提出的从梦想到交付，不仅是对自身发展的历程的总结，更是对未来合作伙伴的承诺。它意味着中国愿意与世界分享经验，共担责任，共创未来。最后，衷心祝愿本次发布会圆满成功，愿我们携手并进，共同推动核能事业的不断前行，为世界能源转型和人类可持续发展贡献更多智慧和力量。谢谢大家。
Thank you, Mr. Cao, and thanks for the continued support from CNEA. And thanks you once again to our distinguished speakers for your insightful and inspiring remarks. Your words have set a strong foundation for today's workshop. Now, with the opening remarks concluded, we now officially begin our workshop, From Dream to Delivery, CNNC Nuclear Energy Solutions. In this session, we have 4 presentations. We will share CNNC's integrated nuclear energy solutions, showcase our advanced capability in nuclear power design and construction, and highlight innovative practice in comprehensive utilization of nuclear energy. Now, I would like to hand over the floor to my colleague, Mr. Lü Chengcheng. Let's welcome him.
Thank you, Mr. Zhang. Good afternoon, ladies and gentlemen. My name is Qian Chen. I am a representative of CNNC European office, and my colleague and I will now do the present on the theme of From Dream to Delivery, CNNC Nuclear Energy Solution. We are China National Nuclear Corporation. We are the premier nuclear energy enterprise and kind of like the backbone of the country's nuclear industry. Yeah, like someone has mentioned this morning, we kind of like EDF of China. Yeah. You know, as a global 500 Fortune enterprise, CNNC is unique on its full coverage of all the nuclear industrial chain. We have business covering like natural uranium, nuclear technology application, environmental protection, finance, renewable energies, and more, and of course, nuclear power plants. Yeah, speaking about nuclear power plants, to fully leverage of the nuclear energy, we offer integrated solution across all the areas such as constructions, uraniums, fuel fabrication, applications, operation and maintenance service, and of course, environmental management. Now, turning to nuclear power plant, we can meet various nuclear power demands according to your market with diverse nuclear designs and engineers. For example, you can see on the picture, we have gas-cooled reactor, water reactor, small reactor, and big reactors. Yeah, speaking about big reactors, normally they are very suitable for the base loads of the power grid. And take HPR 1000 as an example. It is ideal for densely populated regions or energy-intensive industries. The HPR 1000, has already become a very typical and important type of reactor in China's nuclear energy mix. There are some figures about this one. One HPR 1000 unit can supply electricity for over 4 million households each year. And it can reduce carbon dioxide more than 8 million tons every year, equivalent to planting, the trees, more than 17 million trees. And it creates like 10,000 direct jobs and 40,000 indirect jobs. This will actually bring a major boost to the local environment, economic and society, public well-being. Yeah. And also, we all know that SMRs right now are trending. They are gaining more and more popularities nowadays. And one of the SMR we have is HTRPM. In 2023, December, one of the demonstration projects of the high-temperature gas-cooled reactor pebble bed modular has gone into operation in Shandong, China. And this will bring a new option for the nuclear market, not only for electricity supply, but also steam. We all know that, because of the high parameter, you can use that for all kind of a chemical process. And another CNNC small modular reactor is the ACP100. We began to build its demonstration project in 2021, and the plan is to get into operation next year. And by the way, we just finished the code functional test last month. The ACP100 is one of the most advanced, of course, in terms of construction period progress. Yeah, it is small. It is integrated design. It is flexible for small or medium-sized power grid. You can use that for electricity supply, for steam supply, for seawater desalination, all kinds of multiple applications. Yeah, we all know that during the last decades, a lot of the Generation 3 nuclear power plant has faced delays and budget overrun. I think the number can reach up to like average 8 years, and the budget can rise up to more than double. But all of CNNC's Generation 3 nuclear power plant has been finished ahead of schedule and within budget. Of course, the reason to that is with efficient construction management. Now, I know some of you might say, that's great, but we've already done that in Europe and America many years ago, achieved that. But yeah, let me just put it this way. Imagine yourself going back to university and take a math examination and get 4 marks at your first try. I know you can still do that, but it's going to be really challenging, right? Yeah. That's why we've been doing this for the last 40 years, and we are still doing that, and we are getting better and better. Like Lady Summer has said, it's not about building it fast, it's about building it right. But it's even better if you can do them both. Yeah. Very humble, yeah. Yeah, of course, yeah, trying to stay humble, yeah. And talking about fuel supply, yeah. CNNC is China's only full-cycle nuclear fuel supplier. From exploration to uranium mining, we have the professional teams and advanced technology to secure our fuel supply. We make all different kinds of nuclear fuel elements. As you can see on the pictures, like a pepper bed fuel with the tracer particle, and also all different type of like a heavy water reactor, light water reactor. We can, all of the business we can cover. And also CNNC is one of the biggest nuclear application companies in China. We account for more than 80% of the research and development and produce capabilities in China. And we offer more than 17% of the nuclear medicine in the Chinese market. Well, with a large fleet and professional team, we continuously improve our operations and maintenance. We can cover all the business areas across like technical service, outage service, technical modifications, spare parts supply, the operation support, etc. And as you can see on the picture, we can cover almost all different types of reactors. When it comes to environmental protection, CNNC offers services in the radioactive waste management business. We can do like the radioactive waste acception, treatment, disposal, and also like a decontamination, dismantling, and decommissioning of the nuclear facilities. So to our global client, CNNC offers specialized service across all the nuclear sectors. That commitment also extends to talent development. We offer specialized training programs, professional educations, partnership with top universities with scholarship. We welcome all the collaboration all around the world to advance nuclear together. All right, ladies and gentlemen, that is a brief introduction about CNNC. The story continues as my colleague will dive deeper into our research and delivery capability, proven delivery, and diversified application. Okay, Mr. Li, you have the count.
Thank you, Mr. Liu. So good afternoon, ladies and gentlemen. So it's my great honor to introduce the overall R&D and also the design capabilities of CNNC. My name is Fan Li. I'm from the China Nuclear Power Engineering Company, who is the EPC contractor in China and also the designer of HPI 1000 and also ACP 100. So let's proceed over the presentation. So CNNC has more than 40 years uninterrupted R&D experience. Okay, from the very beginning, the Qingshan Phase 1, which is a 300 megawatt electricity nuclear power plant, which was built in 1985, 40 years ago. And then we built our own 600 megawatt called CMP 600. And then after performing self-reliance R&D, finally we have our own third generation large-scale nuclear power plant called HPI 1000, also known as Hualong 1, and also ACP 100, the SMR. Okay. So this slide shows the mature institutions and also companies who has been involved in the R&D of CNNC. So those four companies belongs to the subsidiaries of CNNC. The first one is my company, the CMPE. So CMPE is the general designer of the whole plant. Okay, so we can supply integrated solution for the whole plant R&D and the engineering design. And the second one called NPIC. NPIC is mainly focused on the PWR design and the PWR fuel design, and also the entry fire system, the nuclear steam supply system design of PWR. The third one called CIAE. So this one is mainly focused on the sodium-cooled fast reactor design. So, and also the fuel for the fast reactors. So the first one is a very interesting one. So we call it CMPO. So this one is mainly for the R&D and research on the operation and maintenance, such as inspections, such as repair and maintenance. So those technologies. So not only we utilize our own subsidiaries to perform R&D, but also please notice that every year we have about 8 or 10 units put into construction. So we will utilize all of the industrial chain in terms of the R&D and the design. So there are so many universities involved in R&D of new reactor types. And also there are other companies or other institutions involved in the engineering design for the HPI 1000 and for ACP 100 and also for other reactor types in China. So totally we have, in the whole chain, we have more than 50 members. So, and they can provide comprehensive solution for R&D and for engineering design for real projects. So this slide shows the main nuclear power brand of CNNC, covering PWR with different capacity and also sodium-cooled fast reactor and also HTRPM, as also been introduced by Mr. Liu. Okay, so for PWR, we have series of PWR. The largest size called HPI 1000 with the capacity of 1200 megawatt electricity, and the medium one we called ACP 600 with a capacity around 700 megawatt. And also a smaller one, okay, well, very interesting one is SMR called ACP 100. So the capacity is 125 megawatt. So we have two kind of fast reactors. So they both belongs to sodium-cooled fast reactor. So 600 and also 1200. And for the HTRPM, also we have two types of them, okay. The two types are distinguished by the numbers of the modules. If two modules construct together, that we call HTR 200. If 6 modules construct together, we call HTR 600. So if you have any interest of this detailed design, you can go to the exhibition area of CNNC, okay. So I will introduce for some detail one by one, okay. The first one is HPI 1000. So please notice the construction progress of this technology. The first one, as mentioned by our leader, yes, the first one was put into commercial operation 2021, January. So achieved the shortest construction period as 68 months. So that's very short for the first demonstration project. But now we have 7 HPI 1000 in operation, both in China and in Pakistan. So there are other 17 are under construction, under real construction. And also another 17 has been approved by the State Council of China, which means that those approved 17 units will be put into construction in next few months or next 18 months, okay, according to the requirement of the government. So approved units should be constructed in 18 months, okay. And then another 20 more units will be planned into construct in China and also in other countries. So the second one is the ACP 100, the SMR. The nominal electrical power will be 125 megawatt, and the plant lifetime will be 60 years, and we have a long refueling length as 24 months. So this will ensure a very high plant availability, larger than 90%. So it can reach the safety target for third generation nuclear power plant. Or we can say that it can reach 1 order of magnitude better than the regulatory body defined by IAEA by 1 order of magnitude for the safety targets. So this is the progress of the project. Actually, the first one has been constructed in 2021, and last month we have just finished the code functional tests. So we anticipated this first one will put into operation in the early of next year, 2026. Okay, this one is also very interesting one. As I mentioned, is HTRPM is 2 module of reactors, but 2 module reactors and 1 turbine. And this one, now we are proceeding this HTR 600 project. So this project, we have 6 modules in a single containment, but with 1 turbine, okay? So this one has been put into operation in 2023, and that one will be put into construction maybe in next year in Jiangsu Shui province. And I will give you further explanation in the cogeneration introduction. So we have totally in CNNC, we have totally experienced human resource with more than 70 disciplines in 11 mature fields. So the total number of engineers or specialists are more than 10,000. So you can see we have a strong capability covering these different disciplines from the reactor design, from the equipment design, and also electrical communication, and also balance of plant, and also conventional element design. So also we have constructed several large R&D base to proceed the R&D program. So this base located in Langfang, which is in the southeast of Beijing, just 70 kilometers from Beijing. So this one, Langfang, we have several large platforms to verify the some phenomenon of the new reactor types, such as this one. This one is the world's largest containment experiment for the structural bearing capacity after severe accident. And this one is also a structural, also a containment test platform called passive heat removal test. But this one is for the thermohydraulic heat removal system verification platform. And now we can not only hand over a real physical plant, but maybe in the next few years, we can handle a totally digital plant. So our goal is we can use the digital technology in the design process, in the construction process, and finally, we can hand over a digital plant to the owner for the long-term operation and maintenance. So you can see in the design part, we have developed different discipline digital platforms, such as the plant plan design, the piping design, the layout design, and also the equipment design, and also for the safety analysis, accident analysis simulation platform. So in near future, the two-dimension documentation and drawings will be reduced as much as possible. So in future, maybe the three-dimension delivery, not only to the construction team, but also to the owner, can be fulfilled in the near future. And the AI is a very hot topic, okay? So now we are using more and more AI technology, automation, operation technology, and also radiation tolerant device, automatic equipment, robots, and also wireless technologies, and also smart wearables to make the plant more smart, more intelligent. So the total target and the function is to achieve smart construction, automated operation, and the predictive maintenance of the equipment, such as some rotating equipment, the cooling water pump of the plant, and also intelligent emergency commanding of the accident conditions. So in near future, maybe the operator workload and also the field workload of the operators can be significantly reduced by applying those intelligent technologies. And this one is, as mentioned by Mr. Liu. So this one is a very interesting project called Jiangsu Xuwei project. In this project, there are 4 HPR 1000 PWR combined with 2 HTR 600 high temperature gas cooled reactors. So the HPR 1000 will heat up the cooling water to be saturated steam, and then the HTR to using the high temperature of the features, so it can overheat the saturated steam to overheated steam. And then we can supply different levels of the steam to the customers nearby. So there is a large petrochemical park nearby this project. So we can see, sell different pressure and different temperature steam quality to the customers. So this is real happens in the Jiangsu Xuwei project. So because CNNC has a very integrated industrial chain covering design, construction, operation, maintenance, and also commissioning. So in the design phase, we can fulfill the needs of the construction teams and to fulfill the needs of the manufacturers. For example, we will use more and more modular design in our design phase to achieve modular construction. And also we will use more and more, in the design phase, we will try to reduce the difficulties for the equipment manufacturer, such as we can lower some place of some key equipment to lower the seismic spectrum. That means that the seismic qualification of the equipment can be significantly reduced. So that's why we call it combined with design and construction and combined with design and manufacture. And also by massive construction of HPI 1000, we will optimize our design step by step by the experience feedback of the previous project construction and operation. Okay, that's my conclusion. So we are willing to cooperate with all of the other countries interested in the fields of scientific research, technology, innovations, and the market development. So that's my presentation. Thank you very much. Okay, I will leave the floor to, the Ms. Fan. Okay, please, Ms. Fan.
So thanks for my colleagues' detailed introduction about the our diverse and advanced design concept. Maybe you have a question now that how we make this fabulous design into reality, because it's a little difficult. It's not just little, it's so hard. So, but I have a question, I have an answer about that because we have a very strong delivery capability. It's my answer. As follows, I can show you some data and show you some examples, then you can find your answers. Okay, follow me. First part, I can show you what achievements have we made that we can call the strong delivery capability. So first, you can see some figures that you should remember. Some figures that, first of all, is 40 years. So since the 1985, the first NPP FCD in Qingshan, we called it Qingshan Phase 1. Then we start to the next 40 years right now. And another number is 33. At this moment, in the mainland of China, we have the 33 units under construction simultaneously. You know, I think it's ranking the first in the world. And in the 2025, we already have nearly 100 units is under constructed or in operation. So please remember these figures. So we now our capability can support more than 40 units to be constructed at the same time. So do you remember these figures? So let's move the next about the duration and about the cost. So this is about the article published this year from the Nature that you can saw this about the cost that since the 1980s to the 21st, then the cost in the US is almost 10 times. In France, it's about 2 times. But how about in China? It's half cost and remains stable. We cost so few, then we break the duration record continuously. Right now you can see all the very first unit like the EPR, like the AP series, we are citing the record, the shortest one under our capability. So, every fellows know that if we want to control the duration, every critical part is an important one. So we separate it into different critical parts. You can see every step we are setting the world record. So that's our guarantee. However, every step we based on the nuclear safety. So this picture is very vivid that you can see the signs that in China in the 1980s and what happened right now. So you can see what happened about management and the technology route. It makes our jump a very leap in over 40 years. So let's move to the next part. Why we have made such achievements is about our capability. So you can see from this slide that the comprehensive management and advanced construction technologies is both very important, but both played a very important role in our delivery capability. So what happened? What implementation about our comprehensive management, like the design and construction integration, reactor fleet management, civil and installation integration, and integrated site construction. So, but today I will focus on the advanced technology, because everyone knows that the technology changes the world. So it's the same. There is no exception in the NPP construction. We use the technology to change the sites. So our keywords is very known by everyone, that intelligent digitalization and modularization. Our capability based on these keywords. So I will give some example to based on these keywords. First, about the intelligent manufacturing. So these slides show our embedded parts factory, which is already in operation in Shandong province. So what happened when we make the production line totally automatic? It increased our production capability 166%. Still, we make our human resource reduced by 90%. This is why we can keep the cost very low and we can guarantee our safety. At the same time, we just research how we can make the embedded parts production line more flexible, more efficient, and more reliable. So this is a mobile factory. Tomorrow, next year, you will see it. So this slide, you can see we can call it intelligent construction way. It means we can build a new method, it's meant containment construction platform. This is why we need to make this platform, because we made some challenge that the HR building is in very critical parts, but it occupied so many equipment resources. So we have to the solution to make this challenge to be resolved. So what we can do? That the platform is integrate assembly of the steel platform and support power packs, hangar, formwork, equipment, etc. into the same platform and enabling multiple level operations and automatic climbing. At the same time, what comes out is make our efficiency improved and at the same time makes the risk and management difficulties dropped so much. So this one is show our modularization technologies. Right now, modularization is a very popular word in the nuclear construction. So this is show how the modularization can contribute to our cost and our duration. So this one you can see only for the civil modulars, we can save the 1.5 months only for one module. Another for the installation that we used in Zhangzhou Phase 2, which is HPR 1000, it's planned 2,000 piping modules. What happened? Its duration is reduced by 6 months. Another, we just combined the civil and installation together. Then what happened? That saved our critical parts by 42 days. So all of this make our duration controllable. So digitalization is always the same in the world right now, so the same in the nuclear construction. This is our new generation. His name is Lean Construction Management Platform. In our system, we call it RAS system. So it's based on the cloud, and we just featured by multiple project database for reactor type coverage and end-to-end process connection and frontline management. Then we can make the progress visualization and digital quality management and visual work instruction. So this is his function. So based on our strong construction capability, watch how we partner with the world. So I think there are so many EDF colleague fellows sit here, and we all think that we have the only international construction training center based on IAEA and CE cooperation framework from the 2011. And in the past 30 years, we already trained 6 countries, almost less than 300 trainings over 30 years. So our objective is always experience sharing and exchanging that makes safe and peaceful development of the nuclear energy. So everyone knows we have almost 40 years for the nuclear. And when we started with EDF fellows. So at the Daya Bay project, our manager, our worker, and our engineer work with the EDF fellows. Then we start. From the Daya Bay to Lingao, then we just come to WNE. Right now, we still work with the EDF, but at this moment, we assist the EDF to make his 6 units planning into reality. So I think it's a benchmark about international cooperation between the Sino and French. I think it's also the model for the world cooperation in nuclear energy. So to the end, I have to conclude by a book. It's wrote by the French fellow. His name is Félix Toyes. The book's name is EDF's Journey in China. So it's a quotation for my conclusion for this presentation. We are sailing in the same vessel on the voyage of the nuclear energy, heading toward a bright and promising future. So thanks to everyone, and next we welcome my colleague to introduce diverse use of the nuclear power. Yes.
Okay, thank you, Mr. Fan. Good afternoon, ladies and gentlemen. My name is Liu Shishuai. I'm a deputy shift supervisor from Tianwan Nuclear Power Plant, CNNC. And it's a great honor to attend this meeting as the first representative of a company. And the next topic I want to share about is diversified application of nuclear energy. Clean nuclear energy has lighted up thousands of homes. In order to meet people's increasingly diversified energy needs, CNNC has taken advantage of its innovation in nuclear energy, keep exploring new scenarios for diversified application. And we have achieved remarkable results such as nuclear heating, seawater desalination, hydrogen production, and island energy storage. One direction of CNNC's diversified application of nuclear energy is to extend the existing nuclear power plants' energy and steam supply. That is, large reactors supply steam and energy to the factories and the municipal or urban heating system. In 2022, the urban heating system project was officially put into operation in Haiyuan, Zhejiang province and Haiyang, Shandong province. And during the past 5 years, this project has gradually spread in China. In Tianwan Nuclear Power Plant, which is where the plant I am working for, this project is called Heqi 1, and it has a steam supply of 4.8 million tons annually to the factory, and which is equivalent to saving 400,000 tons standard coal and reducing 2.91 million tons carbon dioxide emission, and achieving afforestation of 2,900 hectares. As it was mentioned by Mr. Fan just before, not early before, nuclear heating is undergoing changes in Xuwei, Jiangsu. The project is called Xuwei Jiangsu Nuclear Heating and Power Generation Projects. It is under construction right now. It's a combined construction of 2 HTGR and 4 China's Hualong units. Through taking advantages of different types of nuclear reactors, it can provide green electricity and higher quality steam and distilled water to the petrochemical industry about 7.8 kilometers away. So we all know that steam comes from water, yes, but where does the water come from? In Tianwan nuclear power plant, a seawater desalination system was officially put into operation in 2024. As of May 30, 2025, this system has operated continuously and stably for more than 300 days and with a total freshwater output of 3.656 million tons. This project has helped us, including the petrochemical industry, to reduce reliance on fossil fuels and achieved coordinated development of nuclear energy and freshwater resources. The other direction of CNNC's diversified application of nuclear energy is to take advantage of advanced nuclear technologies. For example, SMR. In 2021, the Linglong 1 small modular reactor started its construction in Hainan province. It is the world's first small modular reactor that has passed the IAEA's safety review. And thanks to its features of small construction period and flexible deployment and suitability to distributed energy systems, the Linglong 1 reactors, they are suitable for a number of scenarios such as energy supply to small or medium-sized towns, islands, port facilities, and maritime development facilities. And CNNC has never stopped its efforts to explore diversified application of nuclear energy. This, again, in Tianwan nuclear power plant, the onshore project of the nuclear thermal PV energy storage multi-energy complementary demonstration project started construction in 2022. This is a green and clean innovation and demonstration project. It holds great milestone significance in promoting and exploring nuclear energy plus new energy development model. And beyond this, CNNC will continue provide integrated solutions such as the load, the energy storage, the grid, to the maritime development and other undertakings through building more onshore nuclear facilities, offshore floating platforms, and new energy facilities and power grid. We will keep offering green solutions to zero carbon islands, zero carbon towns, zero carbon factories, and creating an innovation paradigm of ecological sustainability and high quality development. That is not the end. In Qingshan nuclear power plant, CNNC is producing radioisotopes through heavy water reactors. We all know that heavy water reactors, they have ample internal space and with moderator and coolant separated with each other and high-level neutral flux. So these features give Qingshan nuclear power plant special advantages in producing radioisotopes. Based on Qingshan nuclear power plant, CNNC will keep producing radioisotopes and exploring this diversified application in the area of industry, medical, safety, agriculture, and environment, and contributing value to our diversified life. So that's all for our energy solution to our dream our delivery, and our diversified application. So that's all for my part. Thank you.
Thank you. All the 4 presentations have been finished. If anyone have any questions, okay, please. Only one question from the limited time. Only one question, please.
I'd just like to ask very quickly, in CNNC's experience, is there a trade-off between localization and speed and cost? So when you localize, does it become more expensive and slower?
Mr. Fan Li, please, about the localization and the cost.
Okay, thank you, gentlemen. It's a good question. Actually, we now have several potential customers overseas, okay, in Asia and also in Middle East, in other countries. So localization is a very key factor that all customers has that concern. So actually, we will, as much as possible, to enlarge the localization rate of our overseas project, such as from 25% or 30%. So that's according to the capabilities of the local suppliers, the local design institutes, and also the local raw material suppliers. So according to different situations. So we will actually the real price actually is confidential. I cannot give you a very exact number about price, but what I can tell you that HPI 1000 and also ACB 100 are very competitive comparing with other same type PWR technologies. And also we have the full industrial chain, and we have the full capability to supply main equipment, and also with a large localization rate, we can assure that the customer can satisfy with our price. Thank you very much.
Okay, thank you. For the reason of limited time, I will conclude this workshop. If anyone have any questions, please, you are welcome to visit CNNC booth in K area. We can discuss for more details. One more few words. We believe the development of nuclear energy lead for global cooperation and shared effort. And CNNC is ready to work hand in hand with all partners from all over the world. Thank you again for coming. Thank you for your time. Thank you for your attention. See you. Thank you.